All right, guys, today we're going to look at the third day of dividing radicals. So not only are we dividing, we're also going to be rationalizing our denominators. So let's get started. So here I'm going to start by expanding this out. I'm going to leave 11 hanging out front. I'm going to stretch the numerator, so we have 7 times 7 times, and then there's 5 A's. In the denominator, we'll have 2 times 2, and then 3 A's. So in this case, we're going to cancel what we can of the numerator and the denominator. So I can't cancel the 7s or the 2s, but I am going to cancel 3 A's. Now my index is a 2, so I'm going to circle groups of 2. So I can circle these guys and these guys. There is, oh, and a pair of A's as well. So that means everything gets either canceled or circled. So that really does help us out here. So 11 is still hanging out front, times, in my numerator I have 7A, in the denominator I have 2. Remember, 11 is over 1, so I can even go as far as to multiply this. So 11 times 7 is 77, so it'll be 77A over 2. I know that seems kind of crazy, but definitely worked out that way. All right, here's another. Let's go ahead and stretch it out. Prime factorization of 24 would be 2 times 2 times 2 times, 2 times 2 is 4, times 2 is 8, times 3. And then in the denominator, we would have 3 times n times n. So the only thing I see that I can cancel out from numerator and denominator are the 3's. My index is a 2, so I'm going to circle groups of 2. And it looks like I'm left with a 2 under the radical here. And I could pull out 2's here and n here. So let's see what we got here. So we have 2 times the square root of 2 over n. It's as far as we can go. There is no radical in the denominator, so we're good there. All right, here we go. Let's see what we got. I'm going to start by stretching this out. So this would be 2 times 2 times 2 times 5. And then the b's. Same thing in the denominator. 2 times 2 times 3 times b, b, and b. So let's start by canceling anything that we can from numerator and denominator. So it looks like I have a pair of 2's and 3 b's that I can cancel out. So in the numerator, I'm left with the square root of 10b, and in the denominator, I have the square root of 3. So in this case, we are going to have to rationalize. So I'm going to multiply by the square root of 3 in the numerator and denominator. We have the same index, so that means we can multiply these values. Square root of 3 times 10 would be the square root of 30b. And in the denominator, we would end up with the square root of 9. Now, of course, we're going to take it to the next step and actually simplify where I can. So this would be the square root of 30b over 3. We cannot simplify 30 and 3 because one is under a radical, the other is not. All right, trucking along. I know I'm going rather quick, but remember, you can always pause and start as you need to. So there's that. One, 2, 3, 4, 5, 6, and 7. Good. So now I'm going to go ahead and cancel anything that I can from the numerator and the denominator. None of the values. I can cancel 1, 2, 3, 4, 5 A's. 1, 2, 3, 4, 5 A's. My index is a 2, so I'm going to circle my groups of 2. So when I go to take these out, in the numerator, I'm left with 5. In the denominator, I have 3a times the square root of 2. I need to rationalize. So 5 times the square root of 2 over 3a times the square root of 4. We're almost there. 5 times the square root of 2 over 3a times 2. So 5 times the square root of 2 over 6a. All right, one last one here. 8 is going to hang out in that numerator for me. 7s, I can't do much with that, but in the denominator, I can do a little bit here. So this would be 2 times 2 times 7, and then 3 s's. I'm actually able to cancel out the 7's and an s. My index is 2, so I can circle some pairs. So then I'm left with 8 in my numerator, and then 2s in the denominator. Now, the 8 and 2 are like a fraction. I can simplify. So dividing by 2, 8 becomes a 4. This one becomes a 1. So then I end up with 4 over s. That looks a lot nicer than what we started with.